Virtualization has caused I/O problems for the first time in decades. When things were physical, located on a stack, you could maximize and optimize that stack to be able to handle whatever workload you needed. Things got slow, you knew what to fix. Ooh, I can't get enough throughput, great, I add bandwidth. I can't get enough I/O, great, I add spindles. And whatever the patch of the day is. Solid state, et cetera, but you knew where the problem lied. You knew what your system could handle, and what did we do? We always built for peak doomsday scenarios. So our infrastructure stack in days of old was the opposite of consolidated and well utilized, because we built for the Victoria's Secret moment. 50 million people are going to get online, and then 99% of the time we have way more stuff than we're going to use. Right? Bad math, good output, good performance. We don't want the phone to ring. Hey, you stink. Right? You have a thankless job. No one ever goes, hey, nice networking. Right? No one says that. But the nicest little old lady will kick you right in the butt when her email doesn't work. I can't get that Facebook picture. You terrible people. So, virtualization, as you have all, anybody that's been through this, has created a set of brand new I/O problems we never counted on, because nobody knew this was going to happen. Right? Nobody knew. We've containerized. Why does this happen, by the way? It happens because one VMDK executing one application has a specific workload profile, and all of a sudden they mix and match with another VMDK right next to it. Those interdependencies that didn't exist in the physical world all of a sudden exist. Worse, they're transient. Something happens at 4 o'clock that doesn't happen at noon. These three things happen at 3 o'clock that didn't happen at 6 o'clock. And so not only do they create these problems come in and go out. So how do you fix something like that? In the old days, we fixed something by going, oh, I can understand the problem, and I optimize to the problem. I solve for that because it's a constant. Right? 9 to 5, I have 5,000 users that do X, and we could solve for that. Ooh, this is a different world. This is a massively transient world. The problem, by the time you solve the problem, it probably doesn't exist. And then it shows up again 4 hours later or 4 weeks later, whatever the case is. So these make it hard enough. The solution from an I/O problem perspective today in a virtualized world is to do exactly the opposite that we're intending to solve on the other side, which is to typically over-provision. We buy more stuff, more spindles, more cache, more controllers, more stuff than is optimal from an economic perspective, simply because we can't deal with the phone ringing, and why doesn't this work under this set of conditions? Make sense? Problem 2, perhaps the worst problem today, and it's still tail of the dog, it still follows everything we've ever done. Visibility was hard in the physical world, it is brutal in the virtual world. What is the cause and effect? We know the effect, we rarely can figure out the cause. When everything was systemic and holistic, and the phone rang, and somebody said, why is this slow? The team, sysadmin, all the associated people would get together and kind of scrub through and figure out what changed. It's all about change management when something's bad. Something was good, went bad. What changed? We identify the change, we correct the change. Today, Friday, everything worked great. Monday morning, people are screaming. The business line is screaming. Nothing changed. What happens? VP Ops, whoever it is, gets the team together. Sysadmin, network admin, storage admin, DBA, whoever owns the app, storage guy, on and on and on. The whole team get together. Okay, fellas, ladies, something happened. Go figure it out. What happens? We scamper back to our individual cubes and we look through our very specific myopic set of tools, because I'm the storage guy. I go through my storage logs, and the DBA goes through their logs, and everybody else goes through their own logs, only to stand up and go, not me. Not me. That's not helpful. It's good for you. Way to go, it's not you. But it's these interdependencies and the lack of our ability not only functionally to see things, but we've gotten used to, over the last 15 years, not even talking to each other. because we've gone through the age of specialization where I don't even know how to talk to, I don't know what that guy does. He's a geek. Whew. Right? Very difficult. So all of a sudden now we're kind of forced back into a world where thou shalt communicate. And this is good for humanity, by the way. It's good. You know what's the difference between an introverted IT guy and an extroverted IT guy? The extroverted IT guy looks at your shoes when he's talking to you. Just kidding. I usually say engineers, but when in Rome. All right, second one, here's my joke. System management is a brutal black art. Brutally difficult, because of all the things we just talked about. So here's how I can try and explain it to my wife. If you had a cage, and you took a few monkeys, you put monkeys in the cage, and you set up a ladder in the middle of the cage, and you hung a banana from the top of the cage. Invariably, one of the monkeys was going to climb up that ladder, grab that banana. That's what monkeys do. If you did that, and that happened, at the same time that monkey grabbed that banana, you took a freezing cold fire hose and you squirted the heck out of the other monkeys in the cage. It would not take long for those, if some monkey started climbing that ladder, the other monkeys would beat the hell out of them, right? It would not take long. Fast forward. Now if you rotated out those monkeys one at a time, new monkey comes in, old monkey goes out. New monkey's never seen the situation. Monkey comes in, says, that's a banana. Nobody's going to get that. And invariably will climb up the stairs. The other monkeys will beat the hell out of them. Right? You can rotate every monkey out until there are no monkeys that have seen this situation before. And invariably, one will try and climb up and the others will beat the hell out of them. They just have no idea why. That's system management. Right? I don't know why. Right? I should just end on that one. All right, so visibility, really hard. Really hard. We have not kept up because, again, with so many different physical interdependencies, is it an EMC box on one end, you've got VMware in the middle, you've got HP on the top, you've got Cisco in the middle, kind of stuff. There's still all sorts of these disparate interdependencies. It's part of the reason, by the way, that this whole notion of the consolidated stack is getting play. Because theoretically, and it's not true in reality, but theoretically, by and large, if you could just go to, wow, I can get my brain around, if it's one vendor that had control of everything, that would have to make it easier. And that's working from a marketing message perspective. So just to make everything worse, which you didn't think it was bad enough, we combined mobility. So just in case you could go, oh, I see the red light, we go, no, we're putting it over there, right? It's awful. So it was hard enough. We had interdependencies within some container. A VMDK acts like X over here and Y over here. Now we're going to move them around. It's part of the brilliance and the allure of the whole virtualization principle. Right? It's fantastic. We have to enable this to occur, but whew, you know, we're still treading water, and somebody keeps diving in and doing cannonballs.